The American people have both the right and the responsibility to know the truth about unidentified aerial phenomenon. That truth remains hidden, classified, and silenced by fear, retaliation, stigma, and confusion. Today we are here to help break that silence. Sources close to the Defense Department confirm military officials are seriously considering intercepting the interstellar object 3, Atlas, before it changes course toward Earth. Discovery goes on to follow up and characterization. Impact risk analysis, mitigation studies, but you can't follow up and you can't characterize and you can't calculate the impact risk of something you don't discover. The object's bizarre behavior and impossible trajectory toward Mars has triggered protocols normally reserved for incoming asteroid threats. But what happens if we can't stop it? And what if it fights back? The beginning of it all. The story of 3 Highway Atlas begins with what should have been a routine night at the Catalina Sky Survey in Arizona. On a clear evening in late July 2025, automated telescopes scanning for potentially hazardous asteroids captured images of a faint object moving against the background stars. Initially catalogued as just another piece of space debris, the object's unusual motion patterns quickly caught the attention of astronomers who specialize in tracking objects from beyond our solar system. What made 3 Atlas immediately interesting was its velocity vector. Most objects in our solar system follow predictable orbital patterns around the Sun. But this newcomer was moving too fast and in the wrong direction to be bound by solar gravity. Its hyperbolic trajectory and high speed marked it as only the 3rd confirmed interstellar visitor ever detected by human technology. Previous visitors to Iboris and C 2025 AR2, SWAN had provided valuable opportunities to study materials from other star systems, making the discovery of another interstellar object a significant scientific event. However, the initial excitement about studying pristine materials from another stellar system quickly gave way to confusion and concern. As more observatories around the world began tracking 3I Atlas, the data they collected started revealing characteristics that didn't match anything in the scientific literature. The object's brightness fluctuations, spectroscopic signatures, and motion patterns all suggested something fundamentally different from the natural comets that astronomers had been studying for centuries. The international astronomy community mobilized unprecedented resources to monitor this unusual visitor. Major observatories on 6 continents began coordinated tracking sessions, while space-based telescopes adjusted their observation schedules to focus on 3I Atlas. Within weeks, it became clear that this object would either revolutionize our understanding of natural comet behavior or force scientists to consider explanations that challenged basic assumptions about what kinds of objects drift through interstellar space, industrial materials in deep space. When multiple independent spectroscopic analyses confirmed the presence of refined nickel on the surface of 3I Atlas, the astronomical community faced an unprecedented puzzle. Nickel exists throughout the universe, formed in the cores of massive stars and distributed through space by supernova explosions. However, the concentrations and crystal structures detected on 3I Atlas matched industrial specifications rather than natural cosmic abundances. The spectroscopic signatures revealed nickel alloys with compositions identical to materials used in terrestrial aerospace applications. These alloys require sophisticated metallurgical processes involving precise temperature control, controlled atmospheric conditions, and specific cooling rates that produce desired mechanical properties. Such materials exhibit superior corrosion resistance, structural strength, and thermal stability compared to naturally occurring metal mixtures found in meteorites and asteroids. What makes this discovery even more remarkable is the uniform distribution of these metals across the entire visible surface. Natural objects typically show patchy compositions where different materials got mixed together during formation, creating a mottled appearance when viewed through spectrometers. But 3 Atlas shows consistent metallic signatures no matter which part of its surface reflects light toward Earth. This uniformity suggests either a coating process that covered the entire object or manufacturing techniques that produced homogeneous material properties throughout its structure. The preservation of these metallic characteristics also defies expectations for objects that have spent millions of years traveling through interstellar space. Cosmic radiation and micrometeorite impacts should have altered surface materials over such extended periods, creating the kind of weathered oxidized layers we see on asteroids and meteorites. Instead, 3I Atlas exhibits the pristine signatures of recently processed metals as if it was manufactured within the last few decades rather than eons ago. Laboratory analysis of reflected light from 3I Atlas surface showed crystal grain boundaries and stress patterns consistent with forging and heat treatment processes. X-ray diffraction spectroscopy revealed oriented crystal structures that form only when metals are worked under controlled conditions, then subjected to specific thermal cycling to optimize strength and durability. These characteristics never occur in naturally formed metal deposits, which cool randomly in space and exhibit chaotic crystal arrangements. If 3I Atlas contains artificially processed metals, then some intelligence must have created those materials using advanced technology. The durability required for interstellar travel across potentially millions of years suggests manufacturing capabilities and quality control that exceed current human industrial standards. These materials would need to resist cosmic radiation, micrometeorite bombardment, thermal cycling, and chemical degradation across timescales that dwarf human technological development. The gas cloud that shouldn't be there. The James Webb Space Telescope detected a massive bubble of carbon dioxide gas surrounding the object, stretching out for about 350,000 km in every direction. To put that in perspective, you could fit the entire distance from Earth to the Moon inside this gas cloud and still have room left over. This discovery created immediate problems for anyone trying to explain 3I Atlas as a normal comet. The gas cloud is way too big to exist naturally in space. Think of it this way. When you spray a garden hose, the water doesn't keep spreading forever. Solar wind acts like a constant cosmic breeze that should push gas molecules away from comets and compress them into much smaller areas. The fact that this enormous gas bubble exists at all suggests something is actively maintaining it, almost like an invisible barrier, keeping the gas from dispersing the way it should. The gas composition itself raises additional questions about what's happening inside 3 Atlas. Most comets release water vapor as their primary gas component because water ice makes up the majority of their frozen material. But 3I Atlas produces mostly carbon dioxide, which requires different temperature and pressure conditions to sublimate. This suggests either unusual internal composition or active processes that selectively generate carbon dioxide while leaving other materials unchained. Temperature measurements of the gas cloud reveal another impossibility. The carbon dioxide maintains consistent temperatures throughout its enormous volume, from the surface of 3-2 Atlas all the way out to the cloud's outer edges. Natural gas expansion in space should create temperature gradients as molecules spread out and cool down. But this gas cloud shows uniform thermal characteristics that suggest active heating mechanisms maintaining specific temperature distributions across hundreds of thousands of kilometers. Even stranger, the gas molecules inside this cloud are moving faster than they should be able to escape from an object the size of 3I Atlas. It's like watching someone throw a baseball harder than their arm strength should allow. The speeds these molecules are traveling suggest either that 3I Atlas has much more mass than we can see, or something is actively accelerating the gas after it escapes from the surface. Neither explanation makes sense for a natural chunk of ice and rock. The energy math doesn't work either. Scientists calculated how much solar energy reaches 3I Atlas at its current distance from the Sun, then figured out how much energy would be needed to boil off enough carbon dioxide to create and maintain such a massive gas cloud. The numbers are off by about a factor of 100. It's like trying to boil a swimming pool with a birthday candle. There simply isn't enough energy available from sunlight alone to power what we're seeing, which means something else must be generating this gas through processes we don't understand. The impossible navigation. Here's where 3I Atlas gets really unsettling. This object, which supposedly drifted in from another star system across distances so vast that light takes years to cross them, is heading toward Mars with the precision of a GPS-G-guided missile. The level of accuracy required to achieve this kind of targeting from interstellar space is so extreme that calling it a coincidence stretches the definition of the word beyond any reasonable meaning. Imagine trying to hit a marble with a pebble thrown from the next state over. Except both the marble and the pebble are moving at thousands of miles an hour in different directions, and you have to account for the gravitational pull of dozens of other objects along the way. That's essentially what would be required for a random chunk of space debris to naturally end up on a collision course with Mars. The mathematical odds are so small that astronomers use terms like statistically impossible when discussing them in professional journal. The approach vector analysis reveals another disturbing detail about the trajectory precision. When astronomers trace the path of 3 Atlas backward through space, it doesn't point toward any known star system within a reasonable travel time. Most interstellar objects show clear origin points that align with nearby stellar neighborhoods where they could have been ejected by gravitational interactions. But 3E Atlas appears to have come from empty space between star systems, as if it began its journey from nowhere in particular. The velocity profile also doesn't match what you'd expect from natural gravitational ejection processes. When planets or stars fling objects into interstellar space, those objects carry specific energy signatures that reflect their escape mechanisms. Rocky materials get ejected at different speeds than icy materials, and the size of the object affects how much velocity it can achieve during ejection. But 3.2 Atlas shows velocity characteristics that don't fit any known ejection scenario, suggesting either exotic formation processes or artificial acceleration during its interstellar journey. What makes this even more disturbing is that relatively small adjustments to the trajectory could turn a close flyby into a direct impact. Natural comets can't make these kinds of course corrections because they don't have engines or guidance systems. But if 3I Atlas could somehow change its speed by just 10 to 15 km/s, it would go from missing Mars to hitting it dead center. That might not sound like much, but it represents more thrust than any natural process could provide, and exactly the kind of precision maneuvering you'd expect from an advanced spacecraft. The trajectory also shows none of the random wobbles and perturbations that should occur when an object travels through the gravitational influences of our outer planets. Jupiter and Saturn are massive enough to deflect incoming objects. Yet, 3 Atlas has maintained its course with the steadiness of something that knows exactly where it's going. This kind of navigational stability suggests either impossible luck or active course correction systems that compensate for gravitational disturbances in real time. The unbreakable object, every comet ever studied by astronomers, exhibits the same basic behavior. When it gets close to the sun, it starts tumbling and wobbling like a drunk person trying to walk a straight line. This happens because jets of gas escape from different parts of the surface at different rates, creating uneven forces that push the comet around in unpredictable ways. It's basic physics, and it's so universal that finding a comet that doesn't behave this way would be like finding a car that doesn't need fuel. But 3.2 Atlas remains perfectly stable, despite releasing massive amounts of gas and dust. It's like watching a balloon that maintains perfect orientation while air is escaping from multiple holes, something that should be physically impossible without active control systems. The engineering required to maintain this kind of stability would need sensors to detect any rotation changes, computers to calculate corrections, and mechanical systems to implement those corrections faster than natural forces can destabilize the object. The rotational characteristics become even more mysterious when you consider how long 3I Atlas has been maintaining this stability. Most objects in space develop rotation during their formation, or acquire spin from gravitational encounters during their travels. But detailed observations show that 3I Atlas rotates at exactly the rate needed to maintain optimal solar heating for its gas production, as if its spin rate was deliberately chosen to maximize efficiency rather than randomly acquired through natural processes. Surface mapping through radar and optical telescopy reveals another impossible characteristic: the absence of impact craters or surface irregularities that should have accumulated during millions of years of interstellar travel. Space is not empty, and objects traveling between stars encounter dust, micrometeoroids, and larger debris that should leave visible scars on any exposed surface. Yet 3I Atlas shows none of these expected battle wounds, suggesting either self-repairing capabilities or protective systems that prevent impact damage. Objects approaching our sun experience temperature swings that would crack most materials like ice on a hot sidewalk. The difference between the side facing the sun and the side in shadow can be hundreds of degrees, creating expansion and contraction forces that tear normal comet materials apart. Yet 3I Atlas shows no signs of structural stress or surface cracking, despite experiencing these extreme conditions for months. Most natural comets develop jets, cracks, and surface changes as they approach the sun because the heating and cooling cycles gradually weaken their structure. Some even break apart completely when the stress becomes too much. The fact that 3I Atlas maintains its shape and continues its controlled gas emissions suggests either materials far stronger than anything found in nature or active systems that monitor and repair structural damage before it can cause catastrophic failure. A tail like a rocket engine. The tail streaming behind 3 Atlas looks nothing like what comets are supposed to produce. Normal comet tails are messy, chaotic things that twist and turn based on solar wind conditions and random gas jets from the surface. They look like smoke from a campfire on a windy day, constantly changing shape and direction as invisible forces push them around. But the tail of 3I Atlas maintains a sharp focused beam that looks more like exhaust from a rocket engine than random gas escaping from melting ice. This precise geometry suggests controlled mass flow rather than natural outgassing. It's as if something is deliberately regulating how much material gets released and exactly where it goes, creating a propulsion system that uses the tail as thrust. The particles in the tail all move at similar speeds and follow parallel paths, creating the kind of uniform flow you'd expect from an engineered nozzle, rather than chaotic escape from random surface heating. The particle size analysis reveals another engineering signature that natural processes cannot produce. When astronomers examined the dust and gas within the tail using specialized instruments, they found that particles maintain remarkably uniform dimensions throughout the entire length of the tail structure. Natural fragmentation produces random-size distributions following power law curve. But the 3 Atlas tail shows narrow size ranges that suggest controlled production methods rather than random breakup of surface materials. Flow dynamics modeling of the tail structure shows characteristics that match theoretical designs for interstellar ramjet propulsion systems. These advanced concepts use magnetic fields to collect interstellar hydrogen during flight, then accelerate it through fusion processes to generate thrust. The tail geometry and particle velocities observed in 3 Atlas match the exhaust signatures predicted for such systems, suggesting technological capabilities that exceed current human space propulsion by enormous margins. The energy requirements for maintaining such a controlled tail are staggering. Any propulsion system capable of operating for the millions of years required for interstellar travel would need power sources that dwarf anything humans have ever built. We're talking about energy generation capabilities that could power entire cities sustained continuously across time periods that span human civilizations. Such technology would represent achievements by civilizations far more advanced than anything Earth has produced. The tail also responds to changing conditions in ways that natural comet tails don't. When solar wind strength varies or when the object passes through different regions of space, normal tails adjust their shape and brightness accordingly. But 3 Atlas maintains its precise beam regardless of external conditions, as if internal systems are compensating for environmental changes to maintain optimal thrust characteristics. When governments get worried, you know something unusual is happening. When members of Congress start asking pointed questions about a comet, Representative Ana Paula Luna didn't just express casual scientific interest in 3I Atlas. She publicly demanded that NASA deploy maximum surveillance resources and keep the American people informed about what they find. Politicians don't typically hold press conferences about chunks of ice unless those chunks are doing things that ice isn't supposed to be capable of. The response from space agencies has been equally telling. NASA immediately began coordinating with international partners to monitor 3 Atlas using every available space-based asset from the Mars Reconnaissance Orbiter to deep space radar networks originally designed for tracking potential asteroid threats. The European Space Agency repositioned multiple spacecraft to provide additional observation angles, while ground-based telescopes around the world adjusted their schedules to maintain continuous coverage. Behind the scenes, intelligence agencies have quietly activated monitoring protocol normally reserved for foreign satellite activities or potential military threats. Classified space surveillance networks that track everything from spy satellites to space debris have been tasked with maintaining continuous coverage of 3I Atlas movements. These systems can detect velocity changes measured in centimeters per second, allowing real-time assessment of any course corrections that would definitively prove artificial origins. The Department of Defense has issued internal briefings about 3I Atlas to military commanders responsible for space operations, treating it as a potential unknown contact rather than a routine scientific phenomenon. Military communication networks have established encrypted channels for sharing observation data between allied nations using protocols typically reserved for coordinating responses to potential threats. This level of security classification indicates official recognition that the object may represent something requiring military as well as scientific attention. This level of international cooperation happens only for events of exceptional importance or potential threat. Space agencies normally maintain independent research programs and compete for limited observation time on expensive instruments. The fact that they're sharing resources and coordinating activities suggests official recognition that 3I Atlas represents something far beyond routine scientific interest. When governments start treating a comet like a national security issue, it indicates serious concerns about what that object might actually be. The technical resources being deployed go far beyond normal astronomical observation. Military radar systems designed for tracking satellites and missile threats have been quietly redirected toward 3 Atlas monitoring.
Intelligence-gathering capabilities typically reserved for foreign space activities are being used to search for electromagnetic emissions that could indicate technological systems.
These applications of national security assets suggest that officials are taking the possibility of artificial origins seriously enough to treat it as a potential first contact scenario. October 3, 2025, will either go down as the day we witnessed the most spectacular natural comet flyby in modern astronomy, or as the moment humanity finally got proof that we're not alone in the universe.